Welcome to Space Secrets English. I'm Mr. Sufian, and today we're hurtling toward the innermost planet in our solar system for an event that's straight out of science fiction. BepiColombo's sixth and final flyby of Mercury on January 8, 2025. This was on just a quick cosmic pit. Stop it. Was a razor-close shave at just 295 kilometers above the scorched surface. The last gravity assist before the ESA JAXA probe slips into orbit around the tiny enigmatic world in late 2026. Imagine a spacecraft stacked like a high-tech sandwich, born from a $2 billion collaboration between Europe's ESA and Japan's JAXA, zipping past Mercury at over 100,000 kilometers per hour. Why go to such extremes? Mercury is a tough nut to crack. Its intense gravity and proximity to the Sun demand 9 planetary slingshots to break just right. This flyby, the sixth in a series starting from 2021, captured breathtaking images, measured exotic particles, and peeled back layers of the planet's rusty secrets. Buckle up as we explore the mission's origins, the heart-pounding close encounter, and the revelations that could rewrite what we know about our solar system's run. Let's rewind to the mission's launch. On October 20, 2018, an Ariane 5 rocket blasted BepiColombo from French Guiana, carrying a trio of modules: the European Mercury Planetary Orbiter MP, Japan's Mercury Magnetospheric Orbiter, MEO, and the Sun-drenched transfer module that keeps them stacked during the 7-year cruise. Named after Italian physicist Giuseppe BepiColombo, who cracked the gravity assist code for Mariner 10 in the 1970s. This probe is no lightweight tourist. MPO, ESA's workhorse, packs 11 instruments to map Mercury's surface in high-res detail, sniff its wispy exosphere, and probe its bizarre magnetic field stronger than expected for such a small rock meal. JAXA's contribution dives into the magnetosphere, tracking how solar wind sculpts the planet's invisible shield. The flybys aren't detours, they're essential fuel savers. After Earth and Moon in 2020, to Venus zips in 2021. And now, 6 Mercury grazes from 2021 to 2025, BepiColombo has shed speed like a pro racer, aligning for orbit insertion in November 2026. Thruster glitches in 2024 delayed things by a year, but this mission's resilience shines solar electric propulsion, sips sunlight for thrust, making it the first to reach Mercury without chemical rockets alone. January 8, 2025. Dawned tense at ESA's control rooms in Darmstadt, Germany. At 5:59 UTC 6:59 CET, BepiColombo screamed in from the dark side. Its closest approach, shrouded in Mercury's night, too shadowy for the main cameras, but perfect for particle hunters. 7 minutes later, as dawn broke over the North Pole, the monitoring camera's MCA MIS fired up, snapping 50 shots in black and white glory. These low-arrays eyes, mounted on the transfer module, were saying goodbye. They'll detach in September 2026, leaving MPO and MEO to polar orbits. Starting early 2027, the first image dropped January 9th during ESA Director General Joseph Ashbacher's briefing. A sweeping vista of the sunlit north, scarred by craters like Prokofiev and Kandinsky permanently shadowed pits that might hide water ice. A tantalizing hint of resources on this airless inferno. Zooming closer, MCAM2 caught Mendelssohn Crater, a lava-forged basin echoing Scotland's Fingal's Cave, with fresh volcanic vents spewing bright ejecta. The third stunner, a mosaic revealing colorless basin, Mercury's granddaddy impact at 1,500 kilometers wide, ringed by ghostly rays from ancient blasts. These pics aren't just petty, they map surface ages, dark weathered lowlands versus fresh, reflective highs, clues to Mercury's volcanic past and bombardment history. But visuals are just the appetizer. The real feast was in the data deluge. As BepiColombo pierced Mercury's magnetatilla comet-like wake of plasma dragged by solar wind particle detectors like Serena, ESA's exosphere sniffer and MPPEJAXA's plasma probe went wild. They sampled electrons in uncharted zones, sparking refueling where solar particles recharge the magnetosphere's depleted lobes. For the first time, mid-infrared scans from Mercury's pre-flyby in December 2024 pierced the surface, revealing mineral compositions. Sulfur-rich rocks hinting at a volatile pore formation. Unlike Venus or Earth, the flyby's unique path are back-to-back, With December's 5th pass-let instruments calibrate in tandem, fine-tuning for orbit ops. IRAP's Mercury Electron Analyzer nabbed spectra from dawn-dusk flanks, exposing hybrid plasma waves that might explain Mercury's hollow core, 85% of its radius. These aren't trivia, they tackle big questions. Why does Mercury shrink while cooling? How did it dodge vaporization near the Sun? And that wonky 322 spin orbit, danced tidally locked in a waltz keeps one side eternally scorched. This flyby isn't an end. It's a prelude to revolution. In 2027, MPO will circle poles every 8.5 hours, mapping 100% of the surface at 25-meter resolution, sniffing sodium and potassium in the exosphere, and magnetometering reconnection sites, where solar wind bites, MEO in a wider loop, will tag solar energetic particles slamming the night side. Together, they'll simulate Mercury's dynamo, probing if its core is layered or molten keys to planetary birth in the early solar nebula. Discoveries could spill over. Better space weather models for Earthsats, or insights into exoplanets hugging red dwarfs, as Geraint Jones, BepiColombo's project scientist, said. These flybys have given invaluable intel on the little explored planet. With a one-year extension possible, expect 10,000 orbits of data gold. So, what mysteries will BepiColombo crack next? Ice in craters or magnetic ghosts? Share your predictions below. Like if Mercury's hooked you, and subscribe for our dive into black hole mergers. Thanks for exploring with space secrets. Udo, stay curious. Gaze sunward.